Okay, so today we're going to go over the problems for day 2. Again, I want you to try these on your own. So if you haven't tried these yet, try them first, and then you can come back and watch the video. I'm going to post the answer key first, so you can check the answer key, see if you got them right. If you got any wrong, you can go back and watch this video to figure out what the mistakes were. So day 2, application of our formulas, try on your own, then watch this. So example 1, an auto manufacturer produces 7 models, each available in 6 different colors with 4 upholstery fabrics and 5 interior colors. How many varieties of the vehicle are available? Okay, so again, I have 7 models to pick from. Each of those models can be in any of the 6 colors. They can have any of the 4 upholstery fabrics and any of the 5 interior colors. So this is going to go back to being just a fundamental counting principle problem, okay, which would be you have your slots. Okay, 7 models, 6 colors, 4 upholstery fabrics, 5 interior colors. So we're just going to multiply those together. And we see that there are 840 varieties of this vehicle. Next one, if a college offers 400 courses, 20 of which are math, and your counselor arranges your schedule of 4 courses by random selection, how many of these schedules do not include a math course? So originally you think your N is 400. And then we find out 20 of them are math, and I don't want math classes. So I'm going to take off that 20 and look at only there being 380 courses to pick from. So if I have 380 courses to pick from, okay, and I'm arranging my schedule, so it's the order of these classes would matter then. This is a permutation. And again, you can use your calculator to do that calculation. And this should be a pretty large number here. And it is a very large number. Put those commas in there, and we do find it's in 20 billion different ways that this could happen. So when you think about scheduling for college classes or school here, there are a lot of different ways that kids could end up in different classes. Okay, 4 financial planners are to be selected from a group of 12 to participate in a special program, and how many ways can this be done? So I'm just picking 4 financial planners, nothing special about, why I pick what you get picked for. It's not like one's for one job, one's for another, just 4 getting picked. 12 of them to go. Since our order does not matter, this is just going to be a combinations. So 12 combinations of 4. And that comes out to be 12, choose 4. 495 ways. Okay, next one, an experiment on the plant hardness. Okay, a researcher gathers a wheat plants, 3 barley plants, and 2 rye plants. Okay, and she wants to select 4 plants at random. And how many ways can this be done? Okay, well, we look at how many total we have. We have 6 wheat, 3 barley, 2 rye. And I'm picking 4. So 6, 3, and 2 give me 11 to choose from. I'm picking 4. So we got NCR again. 11, choose 4. 330 ways. Then the next one says, in how many ways can this be done? Exactly 2 wheat plants must be chosen. So we got to figure out how many different ways can I pick the wheat plants. Well, there's 6 wheat to pick from, and I got to pick 2 of them. And then our others can be a mixture of the rest of the types that we have, which is rye and barley, and there's 5 total, and I'm going to pick 2 as well. And so this is fundamental counting principle with these together. It's how many ways this can happen, how many ways this could happen. Okay, so 6 choose 2. We get 15. 5 choose 2. We get 10. So we see that there's 150 ways. So again, we looked at how can we pick the wheat? Exactly 2. Well, there's 6 of them. How many different ways can I pick the 2? And then I have to pick 2 more to have 4 plants total out of those other 5. And then I'm going to multiply those together. Okay, example 5 here. A typical combination lock for a padlock consists of 3 numbers from 0 to 39. Find the number of combinations that are possible with this type of lock. If a number may be repeated. So when you see this combinations, you think, oh, I should be using combinations. You gotta be careful. Combination here is just referring to the ways that we can open this lock. So it's not referring to our normal idea of combinations. Really, this is going to go to that slot method. You have 3 numbers for your password. If we go from 0 to 39, that is 40 numbers. I can repeat them, so really I just have 40 for the first spot. I have 40 more for slot 2. And I have 40 more for slot 3. So I end up with 64,000 combos. So when you think about the combos on your locker or what you use for your P locker room, they do have a lot of choices that they are able to make from there. The next one, 7 workers decide to send a delegation of 2 to their supervisor to discuss grievances. How many different delegations are possible? Okay, so there's 7 workers. We're sending 2. Doesn't matter which is which, so it's just going to be a combination. So 7 choose 2. Okay. Use our calculator. We find that's 21. If it is decided that a certain employee must be in the delegation, how many are possible? Well, if we know this certain one has to be in there, that first person is just a 1. That one person must be in there. Okay. And then we know that in the other spot, we have 6 people now to pick from, and I got to pick 1. Well, 6 choose 1 is just 6, so 1 times 6 is 6 possible ways for this to happen. Okay, so yeah, if that one person has to be in it, there's only 1 option for it, and then I have 6 to fill it. And the last one, if there are 2 women and 5 men in the group, how many delegations would include at least 1 woman? So we got to think about the 2 scenarios. That W is equal to 1 or W is equal to 2. Okay, so if I think about this, well, if we're talking about W is equal to 2, there's one way. I pick the 2 women. Because that would just be there's 2 women to pick from, and I'm picking both of them. That's 1. If I think about 1 person, 1 woman, well, there's 2 women to pick from. I'm choosing 1 of them. Okay, and then I got to pick 1 of the 5 guys. Okay, so I have 5 guys. I'm choosing 1 of them. Well, 2 choose 1 is just 2. 5 choose 1 is 5. So I have 10 ways in which I could have just 1 woman. I pick this woman and 1 of these 5 guys. And then the other time I pick this woman and 1 of the other 5 guys. And then these get added together and we see that there are 11 ways that this could occur. Okay, our last one here. How many 7-digit phone numbers are possible if the first digit cannot be 0? So if you think about digits, there's usually 10 digits. Going from 0 to 9. And a lot of times when you hear these phone number ones, okay, you're going to be looking at the slot method with 7 spaces. So in A, we know it can't be 0 in the first spot, and only odd digits may be used. So you think about odd, you got 1, 3, 5, 7, 9. You got 5 of them. So I do have 5 choices here, okay? And I would have 5 choices everywhere because that 0 does not affect us at all. And we see that we have 78,125 different ways that this one could occur. Okay, and then the next one, again, the first digit cannot be 0, and the first 3 digits are 481. So we're going to go to our phone number. There's only one option for those 3, 1, 1, and 1. But then the other spots I'd have my 10 number options still. So really this is 10 to the 4th. And we see that there are 10,000 numbers that could occur in this manner. So again, hopefully those went well for you. Tomorrow or in the day, we're going to go to day 3 and talk a little bit about, noticing differences of linear and circular